Okay, so what we're going to talk about today is solving right triangles. And so whenever we're asked to, so let's actually write this down. When asked to solve for a right triangle, we will be given some information about the triangle and our goal will be to find all the missing sides and angles. Okay, so that's kind of going to be the main idea here. So just keep in mind that for some of these problems we may need to use a calculator, because depending on the angles, if it's a nice angle where we have 45 degrees, 30 degrees, 60 degrees, just like from the last lesson, we could use our trig identities to find them. But just keep in mind that you may need a calculator for a portion of this. So if you have a basic scientific calculator with the sine, cosine, tangent functions on it, that'll be good enough. So before we do some examples, let's kind of just write down real quick the formulas that work with right triangles. So just real quick, I want to give you a rundown of what we can use when we have right triangles. So obviously, if we think about it this way, if I were to draw a picture where we have this as our angle alpha, so with respect to alpha, and this is a right angle of course, with respect to alpha, this side is the adjacent side, this side is the opposite, and this is the hypotenuse. So we know when we have a right triangle, we can use our trig functions. So we have sine of alpha is equal to opposite over hypotenuse. We have cosine of alpha is equal to adjacent over hypotenuse. And we have tangent of alpha, which is opposite over adjacent. And of course, the other formula that we have that we can apply to right triangles is the Pythagorean theorem, which we know if a squared plus b squared equals to c squared, which if you remember, c is the hypotenuse, a and b are the other legs. So these will be the main formulas that we'll use to help us find the missing parts of a right triangle. Now of course there will be other parts we'll use where we know, for instance, that all the angles add up to 180, so we could use that fact to help us find the missing angle, but I'm just kind of making a list of some formulas that we should consider when working on solving triangles. So let's start with example 1, and I'm asking you to solve the triangle that's 60 degrees, 420 feet, B, C, angle B, angle C, angle A. Okay, so I'm asking you to solve for this triangle. So what we notice right away, or at least what stands out to me, is since I have two of the three angles, I'm going to go ahead and find the third missing angle because that's the easiest one. So I'm going to go after my angles first. So if I go after angle B, we know that measure of angle B, well, what do I know? This is 90 degrees, this is 60 degrees. So obviously this, whatever it has to be, it has to add up to 180. So the, one way of doing this is you'd say, well, we know that B has to be 180 take away from it 90 and take away from it 60, right? Because if I take these away, what's left of 180 should be angle B. But I'm sure by now you even already noticed that, hey, this is a 30, 60, 90 triangle, right? Because if that's 60, that's 90, that has to be 30 degrees. So this is 30, which how nice is this? Because we know that once we see a 30, 60, 90 triangle, we could find all the other missing sides without any issues as long as I have one side, which notice how I already do have one side given to me. So if I go after the sides now, I'm going to say side B. How would I find that? Well, here's what I know. This side, which is opposite 60 degrees, this is the longer leg. So if you remember, to get from the shorter leg to the longer leg, we would multiply by rad 3. So to get back, I would have to take 420 and divide it by rad 3. So I just don't like the fact that we have the radical in the denominator, because remember, going back, we divide by rad 3. Let's just rationalize this. So divide both sides by rad 3. So this becomes 420 rad 3 over 3, and 3 goes into 420, and it goes into it 140 times, so that becomes 140 rad 3. Okay, and then here's what we know. Once I know that the shorter leg is 140 rad 3, if you remember, to get from the shorter leg to the hypotenuse, all I have to do is just double this. So to find C, that just becomes 2 times 140 rad 3, which 2 times 140 is 280 rad 3. Okay, so notice for this one, we didn't really need calculators to solve for, but the idea here was find all the sides and angles that aren't given to you. So if you notice, angle B wasn't given to me, side B and side C weren't given to me, so I found all the missing sides and angles. So anytime you're asked to solve a triangle, just keep that in mind. You're finding all of the missing sides and angles. Now once you do that, then you're done. So let's look at our second example. So for example 2, we're going to say solve the triangle, which is 49 degrees, 89 inches. So let's call this A, B, and C. So now when we notice this, we say to ourselves, well, the good news is I could find this missing angle. I could find angle A again, because if I have 2 of the 3 angles, then I could easily find that angle. So with that said, I know that angle A, so if I go after the angles, I have angle A will just be what's left of 180 when I take away 90 and 49. So if I do that, I get 41 degrees. So we know that angle A is 41 degrees. So now we need to find side A and side C. Okay, so here's where we notice that, look, I can't use the Pythagorean theorem because I don't have enough information, right? I would need 2 of the sides to be able to use the Pythagorean theorem. So to find the other missing side, I'm going to use trig functions. Okay, so if you think about it, you pick any angle except for the right angle, of course, because these trig functions, we want to work with acute angles. So if I'm going with the sides, and it doesn't really matter which side we start off with, so I'm going to pick to try to find side A first. So if I'm going after side A, I'm going to say, okay, now since my anticipation is to use my trig functions, I have to pick an angle, and it really also doesn't matter which angle we pick. So I'm going to pick angle 49. Okay, so based on this 49 degrees, the question is, which trig function could I use where my only unknown will be side A? So let's kind of think about this. What if I decided to use, for instance, cosine? Now there's a reason why I'm saying cosine, but if I were to say cosine of 49 degrees, by definition cosine is what? Adjacent, which is A, which is good, I want that, over hypotenuse. So what's the problem though? Notice how we get adjacent over hypotenuse, which that's not good because I have 2 unknowns. When I set up an equation, I always want to set up an equation in which I have only 1 unknown, which if you notice, if I'm using this angle, I want the 89 and the A. So based on this angle, the 89 is what? It's opposite, and then the A is adjacent, which that's basically suggesting we want to use tangent. So if I say, look, tangent of 49 degrees is equal to what? Opposite, which is 89, over adjacent, which is A. So notice now I have one equation, and I have one unknown. Now look, this 49 degrees, that's not a nice angle. So to find tangent of 49, which I'll do this at the end, I'm going to use my calculator, and I'll show you guys how to do that. But remember, 30 degrees, 45 degrees, 60 degrees, those types of angles, we don't need a calculator. But for this, we will. So let's solve for A. So to solve for A, first of all, I need to make sure A is not in the denominator. So to bring A up, I'm going to multiply both sides by A, which, what does that give me? It gives me A tangent of 49 equals to, and those A's are going to cancel, 89. And then, since I'm trying to solve for A, I'm going to divide both sides by tangent of 49, which then this implies, what's A equal to? 89 divided by the tangent of 49 degrees. Okay, so now I'm going to use my calculator, and I'm going to say, well, what is this going to be? It'll be 89 divided by, and notice how my calculator has the tangent button right there. So I'm going to press tangent of 49, and it's going to give me the answer, which is 77.366. So let's round that to the nearest tenth. So we'll say 77.37. So that's the length of side A. So we just found side A, which is 77.37. And by the way, notice how this kind of makes sense, because 41 is smaller than 49, so the side opposite 41 should be smaller than the side opposite 49. So if, let's say, I got 100 here, then I would be concerned, because that would be impossible. So I could use the same reasoning to find side C. So at this point we have options. Since I know this side, I know this side, I could use the Pythagorean theorem, or I could say, hey, you know what? To find side C, I can use the same idea. I'm going to use this angle, and I could use any of my trig functions with this angle to help me find C. One other comment I want to make is you don't have to use this angle. You could have also used the 41 degrees. It'll just change the trig function that you use. So let's say if I'm using this angle still, and I want to solve for C, and let's say I want to use 89. So from this angle's perspective, what is that? That's opposite hypotenuse, which that's sine. So I would say, look, sine of 49 degrees is going to be opposite, which is 89 over C. So we do the same thing. We solve for C now. Multiply both sides by C. So you get C sine of 49 equals to 89, which implies, if I divide both sides by sine of 49, I get, so divide by sine of 49, divide by sine of 49. And that gives me C equals to 89 over sine of 49. And if I use my calculator and I say 89 divided by sine of 49, that gives me 117.93. So it's 117.93. So notice how we got angle A to be 41, and then we got side, so maybe on the side we'll write it here. A is 41 degrees. Side A is 77.37 inches, and side C is 117.93 inches. And there you have it. Okay, so now the one other type of example I want to do is the type where we are going to need to work backwards to solve for the missing angle. So for example 3, we're going to say solve the triangle, and let's say this is A, B, and C. That's 18 meters, that's 6 meters, okay? And so we have, what are the sides and angles that we're missing? Well, we're missing side C, which, see, now we could find side C if we want using the Pythagorean theorem. That's no problem. So let's do that real quick. So what would side C be? It'll be 18 squared plus 6 squared equals to C squared. So then 18 squared is just literally going to be 324 plus 36 equals C squared, which implies C squared equals to 360. And then to solve for C, we square root this, and then the square root of 360 ends up being, I think we need to simplify it as 36 times 10, so 6 rad 10, I believe. Okay, so we just found we just found C. So this is side C, and this is in meters. So that is 6 rad 10 now. Okay, now to find angles, see, let's first pick an angle to find. So let's say for the angles, I'm going to go after angle B. Now what's the problem here? Only one angle is given to me, which is this right angle. Okay, now to find angle B, we need to kind of use the idea of trig functions, except now, remember, when we use trig functions, we need to make sure we have one unknown. So now my unknown is going to be B. So it really doesn't matter which trig function we use here, but I'm going to try to go with the nicer numbers, so I don't want to use the 6 rad 10. So let's say I want to use the 6 and the 18. So with angle B, which trig function would I use to take the 6 and the 18? Well, let's see. That's opposite and that's adjacent, which once again, that's tangent. So what I'm going to say is, for angle B, I'm going to use tangent of B is equal to 6 over 18. Which implies tangent of B is equal to 1/3. I just simplify this. So now here's what I want to do. My goal is to solve for B. So in some sense, I'm trying to kind of undo this tangent. And to undo this tangent, I have to take its inverse, right? Because an inverse operation undoes what a specific operation does. So the inverse trig functions that you'll see on your calculator are right above the original trig function. See, notice how there's a sign here, and then in blue that there's a sign to the power of -1. That just means it's the sine inverse. And then this cosine, there's cosine inverse, which is to the -1. So when you see this power of -1 with the trig function, those are your inverses. So what I'm basically telling you is, if I have tangent of B equals to 1/3, and if I want to undo the tangent, then I have to take the tangent inverse of the whole side, which in the process, what is it going to do? It's going to undo this tangent, and it's going to leave me with just a B. Okay, so just keep that in mind. But remember, whenever you take the inverse of a trig function, it's of the entire side. So, and just like any equation, if I take the inverse tangent of the left side, I also have to take the inverse tangent of the right side. So remember, the purpose of the tangent inverse is to get rid of, or to undo what the original tangent is. So this is going to become B equals to tangent inverse of 1/3. Notice how the tangent went away because this tangent inverse undid that tangent, so it gave me B equals to tangent inverse of 1/3. Now to find my angle, I need to plug this in to my calculator. So if I go back to my calculator, and to get to the tangent inverse, I have to press the second button, which is this blue one. So if I say tangent inverse of 1/3, that's going to give me 18.43 degrees. So let's say that's about 18.43 degrees. And now that I found angle B, which is 18.43, I can go back to finding A the easier way, right? So angle A would be just 180 minus 18.43 minus 90. But just to kind of get you guys familiarized with this, why don't we use our trig functions to find angle A as well? Okay, so let's say if I want to use tangent again, what would I get? I would get tangent of A equals opposite over adjacent, which is 18 over 6, which implies tangent of A equals to 3. So to get rid of the, to undo the tangent, I'm going to take the tangent inverse of both sides, which gives me what? A equals to tangent inverse of 3. And then if I use my calculator, I get 71.57 degrees. Okay, so once again, I just used my calculator. So I found angle B to be 18.43. I found angle A to be 71.57, which, by the way, the method I did was just to kind of get you more practice with these inverse trig functions. I would probably find the angle A by saying 180 minus 90 minus 18.43, which would give me the 71.57. Okay, but the main purpose of this section is we're literally going to be solving triangle after triangle. So anytime you're asked to solve a triangle, you're just finding all the missing sides and angles using either your trig functions that we've defined or even the Pythagorean theorem whenever it's applicable. Okay, so that takes care of this section.